We are in chemical bonding. In chemical bonding, we are learning topics: ionic compounds, covalent compounds, Poisson rule, hybridization. Now today, bond parameters. Chemical bonding explains the geometry of the molecules. So in geometry, bond parameters present. What are the bond parameters? Yes, bond parameters. Bond parameters are bond length, bond angle, bond order, bond enthalpy. Yes. So parameters which are present in bond and regarding geometry of the molecule, they are called bond parameters. Bond length is the first one. Second one is bond angle, bond energy or bond enthalpy, bond order, resonance, dipole moment or bond polarity. This dipole moment bond polarity also called mu. So download our app for great discounts on our courses. JEE, EAMCET, Neet, bridge courses, foundation classes also. Free handwritten notes, free study material, previous year questions, free mock tests. Now we see the brief about the bond length. Actually, what is bond length? How we can define this bond length? The equilibrium distance between central atom and other atom. For example, here AB3 is the molecule. So A is the central atom. So the central atom, the distance between central atom, for example here A. So it is the structure or geometry of the molecule. Then the distance between the central atom and other atom. So this distance is called bond length. How we can get the bond length? What are the techniques? With the help of we found the bond length. We find bond length with the help of X-ray diffraction, spectroscopy or electron diffraction techniques. Okay, diffraction, X-ray, spectroscopy, electron diffraction. These are the techniques. With the help of them, we can find easily the bond length. So atoms are very smallest particles. We are unable to measure their distances. For that required special techniques. Now what are the units of the bond length? Bond length units are angstrom units, nanometers, picometers. Now we see angstrom units is equal to 10 to the power of minus 8 centimeter, 10 to the power of minus 10 meters, 10 to the power of 2 nanometers. So see here, 1 nanometer equal to 10 to the power of minus 7 centimeters. In meters, 10 to the power of minus 9. In angstrom units, 10. What about 1 picometer? Because picometers also units for bond length. 10 to the power of minus 10 centimeters, 10 to the power of minus 12 meters. These are units for bond length. Now, statement number 1. The covalent radius of an atom in homodiatomic molecule. So, these covalent molecules, for example, same elements present, same atoms present in covalent molecule. Such covalent molecule is called homodiatomic covalent molecule. For homodiatomic covalent molecule, example, chlorine, hydrogen, oxygen, nitrogen. These are made up of same type of atoms. These are examples for homodiatomic molecules. So in the case of homo diatomic molecules in covalent radius that is equal to half of the internuclear distance between the two atoms which are present in molecule. For example, here AA both contain one bond because they held by bond. That bond is covalent bond. In that, radius is covalent radius. The covalent radius of the A atom in A2 molecule is equal to the distance of A and A by 2. With this formula, we get the radius of the one atom. Now, in the case of the hetero diatomic molecule, heterodiatomic molecules, they contain different atoms. Here A and B both are different atoms. Example, HCl, hydrochloric acid molecule, hydrogen bromide molecule. These two are examples for heterodiatomic molecule. They contain different atoms. In that distance D, A minus B, the distance between A and B is called radius of A plus radius of B. Radius of A plus radius of B minus 0.07 delta x square. So what is delta x square here? Electronegativity difference between two atoms. Because these covalent molecules, they made up of non-metals. So non-metals, they contain electronegativity. That electronegativity difference we also takes in the case of the covalent radius of heterodiatomic molecule. So the bond length between a set of atoms in different molecule always same. For example, we are seeing here OH bond, oxygen hydrogen between bond. This bond length in water molecule. In water molecule also OH bond is present. In H2O hydrogen peroxide OH bond is present. In C2H5OH, in that also OH bond is present. But they are different set of atoms. But OH is same. What is the OH in this? OH bond length is same, that is 0.97 angstrom units. So this is the statement regarding different molecules, but they contain same bond length of the OH, that is 0.97 angstrom units. Now statement number 1, as increase the S character. If we take the hybrid orbitals, sp, sp2, sp3 hybridization. In that S character, so first sp3 hybridization. In sp3 hybridization, carbon-carbon contain single bond. What is the bond diagram? In the case of sp3 hybridized molecule, single bond. In the case of sp2 hybridized molecule, in sp2 hybridized molecule, the bond order is 2. Last one, sp hybridized molecule. Here, in this sp hybridized molecule, the bond order is 3. Now, why I explained here bond order? The bond order related to the S character. In the case of SS single bond, sp3 hybridization, the S character is 25 because as increase in S character of hybrid orbitals, the bond length is decreases. So what about S character in the case of the sp2 hybridized carbons? 33.33%. In the case of the sp hybridized carbons, they contain 3 bonds. So in that, what is the S percentage? Means S percentage is 50. So S percentage here increasing. As increase S character, S percentage. In the case of the hybrid orbitals, what about the bond length? Bond length here 1.54 in sp3. 25% S character, 1.34 angstrom units. In the case of S character here, in the case of the sp2 hybridized orbitals, S character is 33.33. In the case of the sp, so S character is 50. Then clear the statement. What is the statement? S character increases, bond length decreases. S character increases, bond length is decreases. Now next statement. As the size of the bonded atom, increases, bond length increases. Now see these covalent molecules. What is the central atom here? Fluorine. What is the central atom here? Chlorine. What is the central atom here? Br. Here right. Means hydrogens are common here. But what is the different element? Fluorine, chlorine, bromine, iodine. Now what about the size of the bonded atom? Bonded atom size is from fluorine to iodine increases. Size fluorine to iodine increases. Then size increases. What about the bond length? Bond length also increases. Bond length also increases. Hydrogen fluoride less than hydrogen chloride in the case of the bond length. Hydrogen chloride less than hydrogen bromide in the case of the bond length. Hydrogen bromide less than hydrogen iodide in the case of the what bond length. So here HF, HCl, HBr, HI. HI has high bond length due to the iodine size is big compared with the fluorine, chlorine, bromine. The size of the iodine is large. So size of the bonded atom increases, bond length also increases. Bond length also increases. So after the first bond parameter of the bond length, the next one is bond angle. So what is the definition or how we can define the bond angle? The angle between the orbital containing bonded pair of electrons, the central atom in a molecule. So the central atom, for example, central atom is oxygen. So orbital containing bonded pair, if it is hydrogens, so that between central atom and this orbital bonded pair electron, so that angle is called bond angle. Yes. So bond angle also bond parameter. So by spectroscopic method we can predict the bond angle. As the bond angle increases, what about stability of the molecule? For example, here we have the one molecule. So what about stability increases? Bond angle in the case of the molecule increases. So stability also increases. If the number of lone pairs increases, for example, if we take the molecule. So for example, the first molecule contained lone pair 1, the second molecule contained lone pairs 2. Then if the number of lone pairs increases, then bond angle not increases, decreases. So bond angle here decreases. Now we have the examples here. CH4, NH3, H2O. In CH4, central atom is carbon. In NH3, central atom is nitrogen. In H2O, central atom is oxygen. So what about the hybridization of the carbon? sp3. sp3. So what about its bond angle? S. Its bond angle is 109 degrees 28 minutes. Bond angle. Because sp3 hybridized, how many bonds around the carbon? In the case of this carbon, total 4 bonds there. Sigma bonds 4. Okay, bonds 4. What about lone pairs? Here no lone pairs. So lone pairs absent in the case of the CH4. Now come to the NH3. NH3 central atom nitrogen has same hybridization, that is sp3 hybridization. But what about here bond angle? Bond angle here 1092 decreases. 1092 here bond angle is decreases. Why? Because NH3 hybridization is sp3, but here around nitrogen, how many bonds there? 3 bonds present. Bonds 3. How many lone pairs? Because central atom is the nitrogen. Its valency electrons 5. 3 used bond formation. Remain 2 electrons in the form of the lone pair. As here in this geometry we find one lone pair. So lone pair here 1. What about in the case of the H2O? Central atom is oxygen. Its hybridization is sp3. Bond angle compared with nitrogen in NH3 decreases. Why? So oxygen is the central atom. Its geometry is angular, and oxygen contains 2 lone pairs because valency electron 6. Now, how many bonds present around the oxygen? 2. How many lone pairs? 2 lone pairs. Now, question. So, what is the bond angle in the case of the ammonia? 107. What is the bond angle in the case of water molecule? 104. Why? Hybridized molecule same. Hybridization is same. Hybridized molecules means these are all contain same sp3 hybridization. So they contain sp3 hybridization and bond angle is decreased. Why? Reason? Yeah, what is the statement? Number of lone pairs increases. In the case of CS3, number of lone pairs 0. In the case of ammonia, number of lone pairs 1. In the case of water molecule, the number of lone pairs 2. Number of lone pairs increases, bond angle decreases. Bond angle decreases. So due to this reason, bond angle decreased from methane to water molecule. Methane molecule to water molecule. Now, next statement regarding the bond angle. As increase S character in hybridization. As increase S character in hybridization, bond length increases. Okay? As increase the S character, their bond length decreases. But bond angle is increases. Why? Bond angle here increasing. See here. The hybridization, first one sp3. Second one sp2, third one sp. For sp3, example is C2H6. For sp2, example C2H4. For sp, the example C2H2. C2H6 alkanes. Alkanes hybridization is sp3. Alkenes, the hybridization is sp2. Alkynes, the hybridization is sp. For example, alkanes given here C2H6. C2H6. For alkenes, carbon-carbon double bond. For alkynes, carbon-carbon triple bond. S. Now statement. As increase the S character. What about S character is increasing? S character increases, bond angle increasing. The bond angle is increasing. What is the bond angle in the case of the sp3? 109 degrees, 28 minutes. What about in the case of the alkenes? Alkenes, the bond angle. So hybridization sp 180. Hybridization sp2 120. Yes. Then as increase the S character. So S character increasing. So bond angle also increases. Bond angle also increases. Alkenes, alkynes. Alkynes have the bond angle is high due to S character is more. S character increases. Bond angle also increases. Now next statement regarding the bond angle. If En of the central atom decreases, bond angle also decreases. Example, ammonia NH3, pH3, arsenic hydride, antimony hydride, bismuth hydride. These are the hydrates of 15th group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. So here central atom is nitrogen, phosphorus, arsenic, antimony, bismuth. So electronegativity of the central atom from nitrogen to bismuth decreases because nitrogen is small in size. So it has more electronegativity. So electronegativity down these 15th group elements from nitrogen to bismuth decreases. So if central atom is here what? Nitrogen, phosphorus, arsenic, antimony, then its electronegativity decreases. Then bond angle also decreases. What is the bond angle in the case of the ammonia? 107. What about in bismuth? 90. So is it decreased or increased? It is decreased due to the central atom electronegativity decreases. Now come to the text statement. If the central atom is same, other atom electronegativity decreases. So before we spoken here only the central atom is different, but here central atom is same: nitrogen, 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 nitrogen. But other atoms are different. What is the other atom in the case of the first one? Fluorine. What is the other atom in the case of the second one? Chlorine. What is the other atom in the case of the third one? Bromine. What is the other atom in the case of the last one? Iodine. So here central atom is same, but surrounding or other atoms are different, like fluorine, chlorine, bromine, iodine. So fluorine, chlorine, bromine, iodine, they are 17th group elements. 17th group elements more electronegative elements in the periodic table. But fluorine to iodine electronegativity decreases. Fluorine has more electronegative element. What is the last one? Iodine has least electronegative element in that group. Now the other atom electronegativity decreases. What about bond angle? Is opposite for above one increases. Other atom electronegativity from fluorine to iodine decreases. Then bond angle is increases. So here bond angle depends on the central atom electronegativity. If central atom is same, that is depends on other atom. So link in descriptions, Path Store. Path Store contain previous year solutions, full length test, study materials, JEE Mains, Neet, EAMCET, IIT Foundation, and more high quality courses available with great discounts also present. This is our infrastructure. hostel focused study hours, classroom coaching, offline classes, long-term coaching timings, regular coaching also available, and admission started from our branches Narenguda and Medipatnam. So call on these numbers for JEE, EAMCET, Neet. Online coaching also available, live courses regarding Neet and JEE mains, EAMCET. So online coaching also available, you buy and enroll. Call on our numbers. See, these are the videos, live session, maths, physics, chemistry and demand sessions. Same time, the subject-wise classes, they given live classes, daily on demand, live sessions also available. Assignments, everyday assignments, weekend test, grand test and immediate score also available. See, this is showing the score, grade A, B, C, D, E and F. At a time the appear students, time, average score, grade, everything you will get immediately after exam. So our methodology, what is the first one? Basic concepts. For any subject required the basic concepts. Same time, it is not a common course. We are going to write entrance. For that, shortcut methods also required. All model questions, exercise questions, previous questions, chapter wise, weekend test, grand test, test analysis. What is the position of the students in every subject? Yeah. Now after completing the bond length, bond angle. So these two are bond parameters. Regarding bond length and bond angle, we see the types of the questions. In that first one, which of the following set of molecules will have zero dipole moment? Which of the following set of molecules will have zero dipole moment? Dipole moment denotes by mu. Dipole moment denotes by mu. It is actually polarity. What is this? Polarity. In covalent molecule, if covalent molecules two types, polar, non-polar. So non-polar molecules, they contain ionic character. Actually covalent compounds they are non-ionic compounds, but in that due to electronegativity different, polarity is present. Such polarity is called ionic character of covalent compounds. That ionic character of covalent compounds is called mu. That mu is called dipole moment. So now see, which molecules here have the dipole moment is zero. So dipole moment is zero. So they don't exhibit any dipole moment. So what are they? Yes, what are they? For example, see the option 1, ammonia. If we see the structure of the ammonia, ammonia is a what? Pyramid shape. It is not symmetrical. And you take the beryllium difluoride and water, 1,4 dichlorobenzene. So in the case of the ammonia, mu not equal to 0 means ammonia has what? Dipole moment. And water also has dipole moment. Okay, so but we are asking here, dipole moment is 0. Come to the hydrogen fluoride, HF, carbon dioxide and boron trifluoride, yes. But here HF has the dipole moment due to the electronegativity difference. Nitrogen trifluoride, beryllium difluoride, water again has dipole moment because water formula is H2O, central atom is oxygen, has 2 hydrogen. Okay, what about it has mu not equal to 0? Then option A is okay wrong, B also wrong, C also wrong. Now come to the boron trifluoride. Boron trifluoride, boron, this is trifluoride. So trigonal planar, it is symmetrical. When molecule is symmetrical, its mu is equal to 0. Beryllium difluoride, BeF2. So beryllium is the central atom, 2 fluorines. It also contains symmetrical. So its geometry is symmetrical geometry. Then mu is equal to 0. Carbon dioxide. Carbon dioxide shape is linear. Then it is a plane of symmetry. Mu is equal to 0. 1,4 dichlorobenzene. So 1,4 dichlorobenzene also symmetrical molecule. When molecule geometry or plane of symmetry is present, then mu is equal to 0 because they do not contain any dipole moment. So answer is D. Boron trifluoride, beryllium difluoride, carbon dioxide, 1,4 chlorobenzene. Their dipole moment is 0. Even they have electronegativity different elements, but due to their structure, symmetry, their dipole moment is 0. Next question, sixth question. Question number 6. Yeah. Which of the following is the correct order of the dipole moment? Yes. So what is the dipole moment in the case of the question number 6? Yeah, dipole moment is in the case of NF3. NF3 is 0.23 dBars. So dipole moment units are dBars. NH3 1.47 dBars. Now come to the H2O 1.85 dBars. So NF3, H2O, and what is the last one? BF3. Boron trifluoride, its dipole moment is 0. Dipole moment units are dBars. Now see, so NH3 is less. No, NH3 is contain 1.47. Its dipole moment. Its dipole moment is 1.47. BF3 has dipole moment is 0. NF3 has 0.23 dipole moment. NH3 has 1.47 its dipole moment. And highest dipole moment among these molecules 1.85, that is water molecule. So see here, it is the order of the dipole moment increasing. It is the order of the dipole moment increasing. So what is the answer? Answer is B. Yes. In the case of the dipole moment. Next question. The species having bond angles of 120 degrees. So which species has the bond angle 120? 120. Yes. Yeah. So what is the answer? Now we check. Okay. So ClF3. Yes. And NCl3. BCl3. Yes. Question number 7. Yes. What about ClF3? ClF3 is, it is T-shaped. It is T-shaped. NCl3 is pyramidal. It is pyramidal shape. Okay, PH3 also same. Now what about BCl3? BCl3, boron is the central atom. So chlorine, 3 chlorines there. So shape is trigonal planar. Trigonal and planar. So here what about hybridization is sp2. So when hybridization is sp2, what about the bond angle? Its bond angle is 120. So bond angle is 120. So the species having bond angles of 120, the central atom which is contain sp2 hybridization. So in BCl3 boron contain sp3 hybridization, then its bond angle is 120 degrees. Now question number 8. Consider the molecule CH4, NH3, H2O. Which of the given statements is false? Yes. Question number 8. Now first one. Yes. The HOH bond angle in H2O is smaller than the HNH bond angle in NH3. Yes. Okay. Yeah. So next. So actually first we have to see there what bond angles. Yes. So bond angle in the case of CH4 109 degrees 28 minutes, in NH3 107, in water 104. Yes. So now here bond angle is decreasing. Then what about their bond length? Bond angle is decreasing, bond length is increasing. Bond length is increasing. This is the main crucial statement. On that we find easily the answer. The HOH bond, the HOH bond angle in H2O is smaller than HNH bond angle. So HOH means water molecule. So least, then its bond length is high. So HOH bond angle is smaller, wrong. The HCH bond angle is larger. Yes, HCH bond angle is larger. Okay, bond angle is larger. Then HNH, yes, correct, because bond angle here is high, it is low. So B is the correct. The HCH bond angle in CH4, the HNH bond angle in NH3 and HOH bond angle is H2O, all are greater than 90. All are greater than bond angles 90. As they are asking about the bond angle, no, wrong. Yes. The HOH bond angle in H2O is larger than CHC bond angle in CH4. No, it is small. Then this is also wrong statement. Yes. So, what about question number 8? The HCH bond angle in CH4 is larger than HNH bond angle. Wrong. So, the HOH bond angle is H2O is larger than HCH bond angle in CH4. Correct. Because bond angle, yes. Okay. Bond angle is decreasing. Okay. So, what about the case of the question number 8? D is the correct answer. Now question number 9. 9 is, which of the following molecule has maximum dipole moment? Yes. Now we have to find out the molecule's dipole moment. Yes. So for dipole moment required what? Electronegativity different. Here all the molecules, given molecules, they have electronegativity different. Yes. But the dipole moment mu depends on, okay, depends on the geometry, symmetry or plane of the symmetry or non-plane of the symmetry, means unsymmetrical, symmetrical molecules also important. Now we take carbon dioxide. Carbon is the central atom. It has the linear shape. Then same plane, then mu is equal to 0. CH4. So carbon, hydrogen, tetrahedral geometry. So symmetrical, then mu is equal to 0. And come to the NH3, NF3. So NH3, NF3 both have the dipole moment. But in the case of the NF3, the fluorine is more electronegative. So dipole moment, yes, the dipole moment in the case of NF3 take, yeah. So that dipole moment goes to fluorines. But in the case of the NH3, so dipole moment, yes, that is goes to nitrogen. So here in ammonia, compared with the remaining molecules, the dipole moment is maximum due to its structure, and central atom is compared with surrounding atom more electronegative. So in the case of the ninth question, answer is C. So dipole moment maximum for ammonia molecule. Now the question number 10 is the correct order of increasing bond length. CC, CO, CC, C double bond C. Yes. So see here. So bond length. Yes. Which order they given? Increasing order. The correct order of increasing bond length. The correct order of the bond length increasing order is this one, because CH, okay, and CC double bond here, C oxygen here, CC. So this is the correct order of increasing the bond length. So bond length is more, yes, in the case of the carbon. So here carbon oxygen. So size is increased. Then here double bond. Here hydrogen. So what is the answer in the case of the 10th one? Answer is A. Now question number 12. The correct order of increasing bond angles in the following triatomic species. Yeah. These all are triatomic species. Yes. What is the first one? NO2 minus. NO2, last one NO2 plus, NO2 minus 115, bond angle 134, 180. Now I given the hint for you. The correct order of the increasing bond angles in the following triatomic molecules. See, NO2, nitrogen to oxygen. So these are triatomic molecules. Yes, triatomic molecules. Yes. So here first one, yes, see the NO2 plus 180. So it is not increasing order, decreasing order, wrong. Next NO2 plus 180. This also what? 180, okay. NO2 134. Yes. B is the correct option. NO2 minus is less. So then B is the wrong. So what about NO2 minus 150? NO2 plus 180 wrong. So what about NO2 minus 115? NO2 134 180, it is the increasing order, yes. So the correct order of increasing bond angles in the following triatomic species is NO2 minus, NO2 plus. Next, the correct order of the CO bond length among CO3 2 minus, CO2 is, yes, question number 30. Yes. So we draw the structures now. CO, C double triple bond oxygen. Yes. So it has C double bond, okay. Two canonical structures possible. Now in the case of the CO3, yes, CO3, yes, 2 minus. So central atom is the carbon. Double bond, oxygen. Here single bond means one side is double bond, single bond. Here double bond means single bond. Yes. CO3 2 minus. Yes. Now what about here? Yes. What about CO2? Yes. Carbon by this way. Yes. So possible here carbon, single bond. Yes. Now this side is positive, this side is minus. Yes. By this way we got. Okay. Yes. Now the more single bond character in resonance, more is the bond length. Yes. More is the single bond character. So more is the single bond character. Yes. More is the single bond character. Then more is the bond length. Yes. Where is the single bond is more? CO3. Here single bond is 2 there. Yes. So it has the more what? Yeah, CO2. CO2 contain one single bond. CO contain no single bond. So what is the answer? Answer is C. So how we can find out this bond length in the case of CO? CO3 2 minus CO2. depends on single bond. If number of single bonds more, so that one has more high bond length. So CO32 minus contain three structures. Three structures they contain two bond lengths. So answer is CO32 minus. Yes. Now question number 14. The electronegativity difference between nitrogen and fluorine is greater than that between N and H at the dipole moment of NH3 1.5 dipiles is larger than that of NF3 0.2 dipiles. So here given NH3 dipole moment, yes, and NF3 dipole moment. Why? Here what is the difference? Why? NH3 and F3. They both are nitrogen molecules, but why they contain electronegativity different? Because nitrogen fluorine. Above one hydrogen is there, down one fluorine is there. Surrounded atom. So they have electronegativity different. Then why? What is the reason? Question number 14. So for question number 14, answer we say C. In NH3, the atomic dipole and bond dipole are in the same direction. NH3, if you see, the atomic dipole and bond dipole. But in the case of NF3, this is opposite. How? So just now I shown for you. And H3, yes, goes to nitrogen. But in the case of NF3, goes to fluorine side. Yes. Due to that reason, yes, in NH3, the atomic dipole and bond dipole are in the same side. But here changing the direction opposite side. So answer is C in the case of 14th answer. Yes. Now question number 15. The correct order in which the oxygen bond length increases in the following is. So how the oxygen bond length is increases? Yes. So answer is D. How? So here oxygen double bond. Ozone contain one single bond. And H2O2, H2OH. See here. So very simple. So here, why H2O2? O2 is less than O3. O3 is less than H2O2. Means in the case of the bond length, H2O2 is high. Why? Reason is number of single bonds. So number of single bonds increases, its bond length increases. So in the case of O2, any single bonds 0. In the case of O3, any single bond 1. In the case of H2O2, how many single bonds? 3. Number of single bonds increases, bond length increases. Question number 16. The correct sequence of increasing covalent character is represented by. Now we are learning covalent molecules. So we have to find out how the covalent character is increases. How the covalent character is increases. See. So here, yes. Now come to the covalent character is they given 3 elements: lithium, sodium and beryllium. So beryllium is more electronegative, then it is more covalent. Yes. After lithium, sodium. So lithium is electronegative compared with sodium. Yes. So then sodium is least. Then NaCl less than lithium chloride. Lithium chloride is less than beryllium chloride. Yes. So answer is question number 16 C. Because NaCl is more ionic, BeCl2 is more covalent. From NaCl, lithium chloride, beryllium chloride. So sodium chloride to beryllium chloride, covalent character increases. In which of the following would have the permanent dipole moment? Yes. Which one has here permanent dipole moment? That is very important. This also depends on geometry. Yes, now we draw the structure. First one, silicon fluoride. Yes, silicon tetrafluoride. Silicon tetrafluoride. It is symmetrical molecule. Mu is equal to 0. S. SF4. S is the central atom. F. Valency electron 6. 4 participated in the bond formation. 2 in the form of the lone pair. Its mu not equal to 0. Now xenon difluoride. Xenon tetrafluoride. Yes. Xenon valency electrons 8. It has above one lone pair, below lone pair, and mu is equal to 0. Yes. So BF3 also mu equal to 0, because BF3 we learned already. It is plane of symmetry. Then mu is equal to 0. Then see which molecule contain dipole moment is permanent. Yes. Question number 17. Yes. In the case of the question number 17. SF4 is non-symmetrical molecule. It is unsymmetrical. Then its mu not equal to 0. It has dipole moment. So that dipole moment is permanent. So question number 17, answer is B. Now question number 18. H2O is dipolar, whereas BF2 is not. It is because very simple. H2O, BF2 both have the electron negativity different, but H2O is not symmetrical, it is symmetrical molecule. So question number 18, answer is D. Why? Because H2O is angular and BF2 is linear. Angular means mu not equal to 0 and it is linear, then plane of symmetry, mu is equal to 0. Symmetrical, unsymmetrical, that gives dipole moment. So unsymmetrical, mu not equal to 0. Symmetrical, mu equal to 0. Which of the following molecules does not possess a permanent dipole moment? So question number 19. Okay. Which of the following does not, means here which is in linear? Carbon disulfide. Yes. Question number 19, linear. Then, do not possess a permanent dipole moment. Yes. SO3, angular shell. Yes. SO2 also angular, pyramidal. Yes. And H2S, sulfur, hydrogen. Yes. So by this way, which of the following does not possess a permanent dipole moment? Carbon disulfide, because it is linear. Carbon disulfide, it is linear. Yes. So due to its symmetrical molecule, dipole moment becomes 0. Yes. 0. Now last question. Yes. The table shown below gives bond dissociation energies. Okay. So bond dissociation energy Ca 240. Here B 328. Carbon 276 and 485. So here the table shown below gives bond dissociation energies for single covalent bonds of carbon atoms. Element A, B, C and D. Which element has the smallest atom? Which element has the smallest atoms? So on that bond dissociation energy is present. So answer is B. Why? B is what? D. So here, bond dissociation energy high. So then those atoms contain very small. Then their bond length is less. Okay. So answer is B here. D. Okay, these are the bond parameters questions. So we are in bond parameters. We learned only the bond length and bond angle, and we see in our next sessions the remain bond parameters. They are resonance, dipole moment, etc. So thank you, students. Again.